Now we have to see some questions in the example. If we observe the figure, then it is given that D is a point on the side BC of triangle ABC such that angle ADC is equal to angle BAC. Then prove that CA upon CD is equal to CB upon CA, or CA square is equal to CB into CD. Here in a triangle ABC, angle A, and in a triangle ADC, angle D, both the angles are equal. Similarly, angle C is the common angle of both the triangles, and therefore angle ADC equal to angle BAC and angle C equal to angle C. By AA criteria of congruency, we get triangle ABC similar triangle DAC. And now if both the triangles are similar, then corresponding sides are proportional, means AB upon DA equal to BC upon AC and AC upon DC. Here BC means CB, AC means CA, again AC means CA, and DC means CD. Here second and third ratios are taken here, and now if we cross multiply, we get CA into CA, that is CA square, is equal to CB into CD. Now we will see the another question. Here the question is that two triangles BAC and BDC right angled at A and D, means triangle BAC is right angled at A and triangle BDC is right angled at D respectively, are drawn on the some base BC and on the same side of BC. If AC and DB intersect at P, then prove that AP into PC is equal to DP into PB. So in this question the figure is given here. Here ABC and BDC, these two triangles are given. Here both AC as well as BD intersect each other in a point P. And angle A as well as angle D both are 90 degree. So here in a triangle APB and triangle DPC, we have angle A equal to angle D, and that is equal to 90 degree, means both the angles are of 90 degree. Similarly, angle APB equal to angle DPC, because both the angles are equal. Why? The reason is that vertically opposite angles. In this way, by AA criteria, means last time we have seen the AA criteria of similarity, that if the two angles of one triangle are equal to the corresponding two angles of the another triangle, then by AA criteria both the triangles are similar. In this way we have angle A equal to angle D, similarly angle APB equal to angle DPC, and therefore triangle APB, similar triangle DPC. Here both the triangles are similar, therefore corresponding sides are proportional, and therefore we get AP upon DP is equal to PB upon PC. And now if we cross multiply, we get AP into PC is equal to DP into PB. Now we will see one more NCERT question, that is CB also question, and therefore your example is given that E is a point on side AD. Look here, E is the point on side AD produced of a parallelogram ABCD, and BE intersect DC or CD at F. Then prove that triangle ABE similar triangle CFB, similar triangle CFB. And now we will find the solution. In a triangle ABE and triangle CFB, here it is seen that angle AEB means angle E and angle B both are equal. Why? Because the quadrilateral ABCD is a parallelogram, means if parallelogram, then the opposite sides of the parallelogram are parallel to each other, and therefore AD parallel BC means AE parallel BC, and here BE is a transversal, and therefore we get angle E means angle AED and angle CBEF or CBE. Both the angles are alternate angles, and alternate angles are always equal. Here similarly angle A equal to angle C. Why? Because the opposite angles of the parallelogram are equal, and therefore angle A equal to angle C. And therefore by AA criteria of similarity we have triangle ABE similar triangle CFB. Now we have one more example, that is NCERT example. So here observe the figure carefully. In the example it is given that in the figure ABC is a right triangle, right angled at B. ABC is a right angled triangle, right angled at B, and D is the foot of the perpendicular. Here D is the foot of the perpendicular drawn from B on AC, means here BD is perpendicular to AC. BD is perpendicular to AC, and now if DM is perpendicular to BC and DN is perpendicular to AB, then prove that DM square is equal to DN into MC, and second DN square is equal to DM into AM. Now we will see the answers one by one. Here solution, here we have AB perpendicular BC. Here AB is perpendicular BC. Why? Because we are given that ABC is a right angle triangle and it is right angled at B, and therefore AB is perpendicular to BC. Similarly, DM is a perpendicular to BC. Is it correct? So DM is a perpendicular to BC. Now AB is perpendicular to BC and DM is also perpendicular BC. Means BC is perpendicular to AB as well as DM, and therefore AB and DM, they must be parallel. If the two lines are perpendicular to one line, mean if the two lines are perpendicular to one line, then the two lines are perpendicular to each other. Here AB is perpendicular to BC. Similarly, DM is perpendicular to BC, means AB and DM. These two lines are perpendicular to one line BC, and therefore AB and DB, they must be parallel to each other. Similarly, we have CB parallel AB, perpendicular AB. CB is perpendicular to AB. Similarly, DN is perpendicular to AB. Here also CB and DN. Look, CB and DN both are perpendicular to same line AB, and therefore CB and DN are parallel to each other. Hence, quadrilateral, here we have seen that AB parallel DM, similarly CB parallel DN, means quadrilateral BMDN. This here quadrilateral BMDN. So this is the quadrilateral. Is a rectangle, and therefore BM equal to DN or AND, because the opposite sides of parallelogram, they are equal. Now, first question we have to answer here. In a triangle BMD, angle 1 plus angle BMD, angle 1 plus angle BMD plus angle 2 is equal to 180 degree. Why? Because here angle sum property is applied. We know that sum of all the angles of the triangle is 180 degree. Here angle 1 plus BMD is 90 degree plus angle 2 is equal to 180. If we transform 90 degree to another side, then it will become minus. So angle 1 plus angle 2 is equal to 90 degree. Here 90. Similarly, in a triangle DMC, here if we consider the triangle DMC, then we have angle 3 plus angle 4 is equal to 90 degree. Here also we can apply the angle sum property of a triangle, and then since BD is perpendicular to AC, therefore angle 2 plus angle 3 is equal to 90. Now, above we have proved that angle 1 plus angle 2 is equal to 90. Similarly, angle 2 plus angle 3 is equal to 90. Means RHS of both the equations are same, and therefore LHS must be equal, and therefore angle 1 plus angle 2 is equal to angle 2 plus angle 3. Here angle 2 will get cancelled, and therefore we get angle 1 equal to angle 3. Angle 1 equal to angle 3. Also, we can write here angle 3 plus angle 4 is equal to 90. Similarly, angle 2 plus angle 3 is equal to 90. Here both the RHS are equal, therefore LHS must be equal, and therefore angle 3 plus angle 4 is equal to angle 2 plus angle 3. Again angle 3 will get cancelled. We get angle 2 equal to angle 4 or angle 4 equal to angle 2. Now, in a triangle BMD and DMC, here BMD, BMD and DMC, DMC, this angle. So we have to consider here two angles DMC. Then we have angle 1 equal to angle 3 and angle 2 equal to angle 4 here. So by AA criteria means the corresponding angles of two triangles are equal, and therefore by AA criteria both the triangles are similar, and therefore triangle BMD similar triangle DMC. Now if both the triangles are similar, then corresponding sides must be proportional, and therefore BM upon DM is equal to MD upon MC. Or we can write here DN upon DM is equal to DM upon MC. Here we know that DM into DM it will be DM square, and that is equal to DN into MC. So here BM and DN, here instead of DM we have written here DN, because BM equal to DN, because here BM and DN, these are the opposite sides of a parallelogram, and therefore instead of BM we have written there DN, and DN, here DM into DM it will be DM square, and cross multiplication, after cross multiplication we get DN is equal to CM or MC. And now here equation 1 we have to see that we know that here triangle BND similar triangle DNA, BND and DNA, here BMD and DNA means DN and A. So if we consider these two triangles, these two triangles are similar, and therefore taking corresponding sides proportional we get BN upon DN divided by is equal to END upon NA, and therefore we know that again BN equal to DM, so DM upon DN is equal to DN upon AN. Here after cross multiplication we get DN square is equal to DM into AN. In this way we have proved our question. Now we will see one more question, that is in the figure. E is a point on side CB. Here E, if we CB is produced and CB is produced and point E is taken on the produced line CB. So here ABC is an isosceles triangle with AB equal to AC, and if AD is produced, if AD is perpendicular to BC and EF is perpendicular to AC, then prove that. First question, triangle ABD is similar triangle ECF. ABD similar triangle ECF. And second, AB into EF is equal to AD into EC. Now we will see the solution. It is given that triangle ABC is an isosceles triangle with AB equal to AC, means both the sides are equal. If both the sides are equal, then the opposite angles of equal sides are also equal, and therefore angle B equal to angle C. Now in a triangle ABD and triangle ECF, angle ABD equal to angle ECF because both are right angles, and therefore the two triangles, that is angle B equal to angle C as well as angle ADB equal to angle EFC or ECF, both the angles are equal, and therefore by AA criteria we get triangle ADB is similar triangle ACF, triangle ADB similar triangle ACF.